Hello students, last class we have discussed about foundation bolt. So when you are installing a new machine, your basement should be proper. That means when a new machine is kept underneath that foundation bolt, machine should sit in a proper condition. Suppose if it is not in proper condition, means your job accuracy won't be there. Machine may, the job may go taper. Okay, so if the machine is in proper condition, then only you can get the job in good accuracy. Okay, so for setting the machine in a proper condition, for that common instrument is used. Okay, common instrument is used for geometrical test. So today's class will discuss about that what all the instrument is used when you are setting the machines. Okay, so today's class is about common instrument for geometrical test. There is test mandrel. It is called first one. It is comes test mandrel. So test mandrels are widely used as inspection tools during the manufacture and acceptance test of a new machine tools and the repair of old ones. So for example, you take one lathe. So any whaler or any machine you take. Okay, I will take lathe only, HMT lathe. You think that you are working on the lathe. After working for a longer period, that means you are doing a turning exercise and drilling you are doing, boring you are doing, means or you are keeping the job in between center and you are doing taper turning. Okay, offset setting and all you are doing. So after doing that offset setting for a few weeks or whatever it is, so then after later you will get some dimension variation when you are doing turning and all. So that means when you are keeping in between center, when you are holding the job in chuck and in tailstock, you are in revolving center, you are holding the job and you are doing turning, step turning or whatever. When you are doing the step turning, you will find variation in the diameter and all. Okay, one side it is less, one side it is more. That means your center axis of the lathe and center axis of the tailstock, it is not in the center. So for checking that center, one mandrel is required. That's why one solid mandrel is available. Okay, that mandrel you have to keep in between the center. You have to in headstock you have to keep one live center, and in the tailstock you have to keep the revolving center, and that mandrel you have to keep in between both the center, and you have to dial with means you have to dial that mandrel with the dial test indicator. Okay, near that stock in dial test indicator it should show 0 reading. In near the tailstock it should show 0 reading. That means your lathe axis and the center of the tailstock axis should be in same. Suppose if in any variation is there, means you can do adjustment near the tailstock. There is provided one Allen screw. You have to tighten or you have to loosen. So this tailstock adjustment you can do near the back side. Okay. So when it is showing 0 axis on near the headstock and the tailstock, that means you can your job will be in proper this one. That one example, just an example I give. Okay, like this here this mandrel are of same type only. This we'll see that test mandrel are widely used as inspection tool during the manufacture and acceptance test of a new machine tool and the repair of old ones. So here they have shown one jig boring machine. So here one jig boring machine is there. There also same thing. In jig boring machine, suppose the bore and all, if it is taper and all it is there, means you can check with this mandrel. Okay, this is the jig boring machine. So the application of the test mandrel in measuring the swing over of a horizontal boring machine is shown in the figure. That swing and all you can check. Suppose the spindle any variation and all if it is there, means you can check with this mandrel. So this is a jig boring machine. One in dial test indicator they are checking whether it is any taper and all. Suppose if the taper and all is there, means that adjustment and all you can do. Okay. So there are two types of test mandrel. One is a solid mandrel, another one is a hollow mandrel. There are two types. solid mandrel, and other one is a hollow mandrel. So first we will see what is that solid mandrel. So here one mandrel I have shown. Okay, it looks like same that which you are fixing near the tailstock, same it is. So this is a little bit different. So solid mandrel are available in different length, and the diameter must be such that the sag is kept within the permissible limits. Okay, that swing should is kept in between that permissible. Suppose if the swing of that means more, means it will get bend and all. Correct. No? If the diameter of that means the length of the this one mandrel is bigger, means due to over length, it will get bend and all. So that and all problem should not be there. That's why the sag is kept within the permissible limit. Okay. This is one solid mandrel. It is available in different length. The diameter must be such that the sag is kept within that permissible limit. That swing and all, it is if it should not be, if it is more, means then bend and all it will come. So you should be very careful in that. So this is a solid mandrel. Next one, hollow mandrel. So in hollow mandrel, that sag and all won't be any problem, because inside it is you can see that inside it is hollow. In hidden line it is shown. Actually it is sectioned. Other one it is in hidden line it is shown. Okay. So in that problem won't come. A hollow mandrel is made in order to reduce the weight of the mandrel. This avoids the sag of the mandrel during inspection. Okay. So in this it is bore, it is hollow. You can see that 3 different steps it is given. So in this that problem won't come. Sag problem won't come. Okay. This mandrel is also must be sized in between center. This is held in between center. This is hollow mandrel. First one it was a solid mandrel. Next one, straight edge. So you can see there already I used straight edge. This is a bigger size. You can see in the second sketch. It is of bigger size. So straight edges are made for testing straightness. So they are made of steel or cast iron. So straight edges are made of steel or else of cast iron. Steel in the sense high carbon steel or else medium steel like that. Okay. Or cast iron. And maybe of 2 meters or 3 meters length of that straight edge. See, bigger it is, not a small one like 100 mm or 150 mm. This length and all is more of this straight edge. So length may be varied from 2 meters or 3 meters length. Okay, they should be heavy. Well ribbed. You can see that in the sketch. So it should be solid, and middle they are given ribs, so that it won't get bend due to shrinkage and all, means due to some this one some material and will get bend and all. For that, for avoiding that bend and all, they are given ribs in the middle. You can see there. Okay, many 1 to nearly 6 to 7 ribs they are given. So they should be heavy, well ribbed, and free from internal stresses. So there should be no internal stress and all in that. Okay. So this bearing surface should be as wide as possible. The checking portion is given wide. You can see there in width wise. It is wide. Okay. This bearing surface should be wide as possible. So this is a straight edge. In next sketch they have shown how to measure that this one. So use of straight edge by using feeler gauge. By feeler gauge, any gap and all, if it is there, they are checking. You can see that in the sketch it is given. Straight edge is kept in one table, and that is checking. And if any gap and all is there, you can put that feeler gauge and you can check. That is a 0.5 mm. This one in microns it is given that in thickness that gap and all you can find out. Okay, this is one more test mandrel. That is straight edge. So this application of straight edge in testing the flatness of the surface is shown in the figure. Same thing it is. Okay. Next one, block spirit level. This actually spirit level it is used for setting the wise and all you have seen. For setting first for wise, bench wise. For setting you are keeping above that jaws and you are tightening. That should be, the bubbles should be in the middle. So this is block spirit level. All 4 side you can check that what is that levelness. Okay, block spirit level. This is called as block spirit level. So a block spirit level is made of a box section with the faces accurately square or parallel. Okay, it is looks like box. You can see the faces are square or parallel, straight it is. Okay, so they are generally made out of steel free cast iron. So this material is made out of steel free cast iron or steel. Okay, cast iron or else steel, medium carbon steel or high carbon steel. Okay, and are used for checking the horizontal and vertical levels of the machine. Actually, normally this is used for checking the horizontal. Horizontal means this way. This is horizontal. Vertical means this way is called straight up. Okay. Best example is a pillar drilling machine. Next sketch they have shown for when you are installing one machine, new machine. Think that you are installing one pillar drilling machine. The next sketch I have shown. So you can see here. You can see that spirit level is kept in sideways, and that bubble should be in the middle. So when you are installing a machine, that drilling machine should be in straight vertical position. Okay, straight it should be. So that spirit level, block spirit level kept, and they are checking that whether it is straight 90 degrees should be there. Okay, we can't use any other instrument, so they have used block spirit level for checking the straightness. So this application of the block spirit level in testing a drilling machine is shown in this figure. Okay. So after the straight, then you have to install that foundation bolt and you have to tighten it. Okay. So today's class we have discussed about test mandrel. There are two types of mandrel. That is one solid and other one is hollow mandrel. Normally it is used in jig boring machine and some other CNC and all. Then other one we have seen about straight edge and block spirit level, where it is used for installing a pillar drilling machine. Okay, you can see in. I hope you have understood. If any doubt means you can ask question or send me in questions in mail. Hope you have understood this lesson. Thank you.